Going to discuss that dilutions of acid and base and pH of the solutions. Okay. Today's topic is dilution of acid acids. Okay. As you know very well that when during the dilutions of acid means dilution of acid is an exothermic process. Okay. Heat is being liberated out during these reactions. So what is going to happen here is that if I'm saying that if you are having a glass, let's suppose you are having some acid, okay, some acid here, okay, and in another one, if you are having the another one, you are going to have water here, and suppose you add some, okay, yeah. So you are pouring water here, and you are pouring here acid, okay, into water. Which one is the more appropriate for dilution? Which one is the correct one? The first one or the second one? Which one is correct? Is there any idea? Shape, is there any idea?
The second one,
Second one, why?
I think it has more water.
Because it has more water. Okay. Okay, so let's start. Yeah, second one is the more appropriate. We can say that second one is the correct way for the dilutions of acid. Why? Because when we say that dilutions of acid and base, dilution of acid or base is an exothermic process. Okay, wait, let me do this one. So dilution of acid and base is an exothermic process. Is an exothermic process. Okay, thermic process. Okay, got it. So when we are diluting any substance, it is an exothermic process. Okay, acid base, but heat is being liberated out. Okay, so what I'm saying here is that, for example, if you are just diluting, if you are adding water to acids, okay, the heat is being liberated out. Okay, and which is more absorbent? You know that water is a more absorbent, or we can the specific heat capacity of water is more as comparison to that of acids. But what I'm saying here, let me explain you one more time. For example, you are having sand. Okay, sand. This is a sand area, and the one is water. Okay, okay. You know that the sun is okay. This is water here. Okay, and this is the sand. Okay, you know the sun is rising. Okay, so do you think that which will get more water? Water, the sand or the water? Tell me, which will get more heat, or which the temperature of which one will more increase more? Tell me which one. Does the sand will gives you high temperature, or the water will? If the sun is rising like for example, sun is rising for the 5 hours, okay, a day. So which will get more heater, sand or a water? If you kept them on both on the open air in the sunlight, which will get more heat? Tell me.
Sand.
Nobody's. Yes,
Sand.
sand. Yes, sand will get more heat. Why? Why? Because you know very well that sand, the specific heat capacity means heat absorbing capacity of sand is less as comparison to that of water. Water absorb more heat, so the temperature will not rise. Okay. For example, if I'm saying if I'm start heating a substance, okay, a substance that is there are sand here, okay, and water, okay. I start heating both of them. It is water for 5 minutes. For 5 minutes, okay. So we will see that the sand will absorb less heat, so the temperature of sand will be more as comparison to that of water, because water absorb more heat, the temperature will not increase. So this is called, that is called specific heat capacity. What is specific heat capacity? Specific heat capacity. Heat capacity, it is the amount of heat that is being required to increase 1 degree temperature of a particular substance. Okay, for example, if I'm saying that you have 18 gram of water, or 1 kg of water, 1 kg of substance. Okay, And if you are heating that substance, 1 kg water, and you have 1 kg of sand, 1 kg of sand, another 1 kg of H2SO4, sulfuric acid. Okay, you start heating them. Okay, you start heating them. Then now this is at 25 degrees Celsius. It is also 25 degrees Celsius. It is also 25 degrees Celsius. And you start bringing it. You start heating it, and you give that. You bring the temperature from 25 to 26 degrees Celsius. Okay, 26 degrees Celsius. So when you increase the temperature for 1 degree, the amount of heat given to this one is called specific heat capacity. So actually, if I say that the if for example, if this H2SO4 takes, if this H2SO4 takes 3500 kilojoule energy for, or joule energy, 3500 joule energy for increasing 1 degree temperature. Okay, then water will take only 1000 joule. Sorry. If I'm just if water take 3500 joule energy to increase 1 degree temperature, then H2SO4 will take only 1000 joule energy. It is opposite. Means water will absorb more heat to increase 1 degree temperature. Okay, because water is a good heat absorbent. Okay, got it. Water take long time to heat and water take long time to cool down. Okay, got it. Yes. You understood it? So when we are heating, when we are cooling this, we are adding this one. Okay, you see that H2SO4 here, the heat will be produced, but the heat produced during this reaction will be absorbed by the acid. But here heat produced during the dilution will be absorbed by water. Since water is a good absorbent, water can absorb more heat, so the temperature of this liquids will not increase as much as in this case. Water, when you are adding water to acid, the temperature will rise suddenly because acid does not absorb heat. So it will increase the temperature at faster rate. While if you are adding acid to water, temperature will not rise because the water will absorb the heat. The heat will be produced, but this time water is acting as an absorbent. Here, here acid is acting as an absorbent, heat absorbent. So acid does not absorb much heat, but water is a good heat absorbent. Okay, so it will absorb the heat produced and will make the beaker cool. Okay, it will not allow the beaker to splash out. Okay, this solution. You understood? You got it? Yes. That why during the so if the question comes in examination, why during dilutions of acid? Why during dilution of acid only acid must be added. Acid must be added to water, but not water to acid. Acids. Okay. So the simple answer for this question is that dilution of acid is an exothermic process. The heat liberated out during the reaction during the dilution may results in splash. Okay, or breaking of beaker. Breaking of beaker. Okay, but okay, if this breaker, if water is added to acid, but if acid is added to water, the heat release because water is 3.5 times would heat absorber than AC. This will prevent certain increments in temperature and splashing. Okay, put it down. Put it
Done,
down.
sir.
Done.
Yes, sir.
Yes, sir.
Okay. So let's move to the next part, that is pH of the solution. This is the question on the dilutions of pressure. Now the next question is pH of solutions. So if I ask you that what is the pH, if I Jobita, uh, have you studied this pH of the solution?
Sir, no, sir. I was absent at my school that day.
Okay, and you, it's name Tejasvi, have you studied this topic?
In my school, I have studied, sir.
No. Did I teach you this one or not? pH of solution, pH, the question related to pH of the solutions. Okay, let me explain you. What is pH of the solution or what is pH? So pH means power, power, power of hydrogen ions. Okay, hydrogen ions. Okay, what do you mean pH? pH means power of hydrogen ion concentration. Okay. Power of hydrogen ions. So you can write it. Okay. So if I'm saying that pH of a solution, what does you mean by the pH of a solution? So pH is a scale that tells us that how much acidic and basic a substance is. Okay. Got it? How much acidic or basic a substance is. So if I'm saying that, what do you mean by pH of a solution? So pH is a scale. pH is a scales that tells us how much acidic or basic a substance is. If the pH is H, okay, note it down. We can write it. This is going to be value 0, then 7, and then 14. Okay. So if a pH of a solution lies between 0 to 7, as in 7, then it is acidic. If it is exactly 7, this is neutral. And if it is 10 to 40, 7 to 40, then it is basic. Got it? Got it?
Yes, sir.
Yes, sir.
Okay, note it down.
Done, sir.
Done? Okay. So let's move further. So I'm saying pH is a scale that tells us how much acidic and a basic a solution is. Okay. For example, if I'm saying that the pH, if a pH of a solution is 2, pH of a solution is 2, then the hydrogen ion concentration of that solution will be 10 raised to the power minus 2. Got it? If the pH of a solution is 3, then the hydrogen ion concentration of that solution is 10 raised to the power minus 3. If the pH of the solution is 7, then the hydrogen ion concentration will be 10 raised to the power minus 7. If the pH of a solution is 10, then the hydrogen ion concentration of that solution is 10 raised to the power minus 10. Got it? So whatever the here, then pH is, the hydrogen ion concentration will be same, but in the negative 10 raised to the power. Okay. If I'm saying what is the, if the pH of a solution is 12, if the pH of a solution is 12, what is the hydrogen ion concentration?
10 raised to minus 12.
10 raised to the power minus 12. Okay. Shweta, you understood? Shweta,
Yes, sir. Yes,
you
sir.
got it? Okay. Shweb, you got it?
Yes, sir.
So if I'm saying that this is the now the question that is being asked in the examinations, that do the pH if I just simple, if I ask you that if the pH is here, okay, you see this is pH is 2 and we are increasing towards the pH. Is the hydrogen ion concentration increasing or decreasing? If I move, if a solutions, if I'm having a solution of pH 2 and then I on dilution, the pH of the solution become 3, will the hydrogen ion concentration increases or decreases in the solution?
Increases.
Decrease.
Increase. Okay, if I ask you that this is the okay, if I'm having this one 10 to the power minus 2, okay, and this is 10 to the power minus 3, that means this is 0.01 and this is 0.001. Which one is greater, this one or this one? 10 to the power minus 2 is greater. So pH, if we increase the pH, as we are increasing the pH, the hydrogen ion concentration decreases. Okay, so we can say that pH of a solution is inversely proportional to hydrogen ion concentration. I.e., I can say that more pH, i.e., more the pH, lesser will be hydrogen ions concentration. Hydrogen. Got it? More the pH, lesser will be the hydrogen ion concentration. Got it? Got it?
Yes, sir.
Okay. Wait a minute. Now let's move further. So if I'm saying that if you are having a solution, that you have two solutions of pH 3 and 6. What? I write two solution. I have written 2 and 2 again. Two solution of pH 3 and 6. What will be the ratio of their hydrogen ions concentration? Tell me. Tell me. What is the ratio of their hydrogen ion concentration? Two solution. We have the solution pH. Well, the solution one is pH with pH 3, another is with pH 6. What will be the ratio of their hydrogen ion concentration? We're saying 1:2. Okay, another students. What is the ratio of their hydrogen ions? 1:2. No, it is incorrect. Search, try to do it. Take the help of that we have written previously.
2:1.
2:1. 2:1. One is saying 2:1. Shweta, what is your answer?
2:1.
2:1. Okay, let's check. If I'm saying the pH of a solution is 3, so what does it mean? What is the ratio? What is the ratio? Hydrogen ions ratio is being asked. So you know that pH is, if pH is 3, then the hydrogen ion concentration will be 10 to the power minus 3. If pH is 6, then hydrogen ion concentration will be 10 to the power minus 6. If the ratio of this and this one is asked, 10 to the power minus 3 divided by 10 to the power minus 6. So you can bring this power to upside, okay, because the base is same. So this will become, or you can write it like this way, 0.001 or 0.0000005 zeros and 1. Okay. Okay. This is the ratio. But you can write it, even you cannot remove the decimals here. You have to bring the decimal place with 6 here. Okay. So what you need to do here is S, or you can do it by simple way, that is simple mathematics rule. That is 10 to the power minus 6. This 6 will goes upside because the base is same. And you have a raised to the power x upon a raised to the power y. You will get a raised to the power x minus y. So simply you can write it 10 raised to the power minus 3 minus 6. Okay, you have to keep it in mind that you have to write here minus and then minus 6. It will become 3, then minus will become plus. So minus 3 plus 6. So this will become 10 raised to the power 10 raised to the power positive 3. Okay, and this is 10 raised to the power positive 3 upon 1. That is 1000:1. Okay, or you can check it like this. For multiplying, you know that if you need to bring the decimals at the same place, after the same place, okay. So here is 6 zeros and here is 3. So you have to place 3 more zeros. Now the decimal is exactly after the 6 digit, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So decimal will cancel out. Now this 0 will not have any value. So this is 1000 upon 1. You can do it like this way. Okay, got it? So the ratio will be, tell me fast. Tell me
1,000
fast.
is to 1.
1000:1. Okay, so note it down fast.
Done, sir.
Abhi, nice within. Abhi, where were you?
Yes, sir. My laptop had some issues, so I had to restart. I have already informed the Learnivio team.
Okay, you have informed the learning. Okay. So we are doing the pH and we have done the important topics. Okay, so you need to watch the recorded video of the portal that you have missed the class. Okay, got it?
Yes, sir.
So if a question is being asked to you, dear students, that do the basic solutions also have H plus signs? So what will be answer? Why? Will you say that the basic solutions also have H plus signs? Here is an NCRT question. Okay, and this is being asked. Let me check where it is. Yes, it is here. Okay, this is it is an NCRT question. How is the concentration of hydronium ion? Hydronium ion is actually H plus ions. Okay, affected when the solution of acid is being diluted. Okay. The question is one. Another one is how is the concentration of hydroxide ion affected when excess of base is dissolved in the sodium hydroxide ions? Okay, and here we also have another questions. Do the basic solutions while diluting acid? Why it is recommended that acid must be added to water, but not water to acid? We have done this question. Okay, and why is dry HCl not change the color of litmus paper? Okay, so dear students, this is very important question. So let's discuss these questions in very much great detail. Okay. So here, let's me check. There are some other questions of NCRT also. Here it is. Do the basic solutions also have H plus ions? If yes, then why are they basics? Okay. So the NCRT is going to ask you the questions. Okay. Let's discuss these important questions. These are very important. Let's take these questions for you. Okay. And these are very important, dear students. So let's discuss each and every questions with a interesting and excited manner. Okay. So if I'm saying here, two solutions, A and B, the pH of the solution is 6 and the another one is 8. Which solution has more hydrogen ion concentration and which of the following, which of this is acidic and which one is basic? So you can simply say that here that the pH is 6 is acidic, and the pH of B solution is greater than, it is less, it is pH 8 more than 7, then it is basic. Okay, simpler. So if I just ask you that which one is going to have more H plus ions, tell me.
Solution A.
Solution A will going to have more H plus ions because it is acidic in nature. You can, if I have written that more the pH, lesser will be the H plus ions. So if you can do this one, we have written this statement in your copy that lesser the pH, more will be the H plus ion concentration, because pH is inversely proportional to H plus ion concentration. So I have written if the pH is 6, then H plus ion concentration would be 10 to the power minus 6. And if the pH is 8, then the H plus ion concentration will be 10 to the power minus 8. So you can see that here the H plus ion concentration will be more. This value is more, 100 times more than this one. Okay, got it? Shweta,
Yes, sir.
Tejasvi,
Yes,
you
sir.
understood? Okay. Okay. What effect does the concentration of H plus ions have on the nature of solution? Okay. The question is being asked, do the basic solutions also have H plus ions? If yes, then why they are basics? Okay. So do the basic solutions also have H plus ions? So can we say that if you are not studying this thing very clearly, so how can you answer this one that the basic solutions also have H plus ions? So let me explain to dear students. Okay. So you know that the pH of the solution, if I'm saying a basic solution, the basic solution means the pH is greater than 7. So let's assume the pH of a solution is 10 to the power, pH is 10, then the H plus ion concentration will be 10 to the power minus 10 here. Got it? Got it?
Yes, sir.
So here is one thing you need to note down here is that it is always for every solution, whether it is an acidic solution or basic solution. If I'm saying this is the H plus ion concentration, the product of H plus ion concentration into the product of OH negative ion concentration is always 10 raised to the power minus 40. It is always, if I'm having a solution that whose pH is, for example, if I'm saying that calculate the OH ion concentration of this solution, how many OH ions will be there? If the pH of the solution is 10, so if the pH is 10, then the H plus ion will be 10 raised to the power minus 10. Then what should be the value of this OH ion concentration? Tell me.
10 raised to the power of minus 4.
Yes, it will be 10 to the power minus 4. Okay, because what should be added to this 10 to the power minus 10 so that it become 10 to the power minus 40? So you know that we have to add 10 to the power minus 4 here. So when you multiply these two, base will be same, so it is 10 and power will be added. Okay, minus 4, minus 10 plus minus 4, you will get minus 40. Okay, got it? So if I'm saying,
Yes,
if I'm writing here that the pH of a solution is here is pH, here is H plus ions, and here is OH negative ion concentration. So if I'm saying the pH of a solution is 2, the H plus ion concentration will be 10 to the power minus 2. Then the OH ion concentration will be 10 to the power minus 12. Okay, when you add this, the power should be 40. Okay, got it? Shoaib, you understood?
Yes, sir.
If the pH of a solution is 5, then the H plus ion concentration here will be, tell me.
10 raised to minus 5.
10 raised to the power negative 5.
And here, OH ion concentration?
10 raised to minus 50.
Minus 9.
So we got 10 to the power minus 9. If the pH of a solution is 10 to the power, if the pH is 7, then
10 raised to minus 7.
and here,
10 raised to minus 7.
10 raised to
that's why it is neutral. That's why at 7 pH, it is neutral because there is an equivalent value of H plus ion and OH negative ion. The acidic H plus ion shows the acidic behavior and OH negative ion show the basic behavior. So if they are equal in numbers, so the solution is neither acidic nor basic, it will be neutral. If I'm saying that pH of a solution is if the pH of a solution is 12, then what will be the H plus ion concentration? 10 to the power minus 12, and here
minus 2.
minus 2. Now you know that this is acidic. This portion is acidic. This is acidic. This is neutral. And this one is basic. This one is basic. Okay, this one is basic. But still it has H plus ion concentration. But you see here that the H plus ion concentration is very, very less as comparison to the number of OH ion negative concentration. Okay. Here it is 0. If the pH is 12, then it is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This number of H plus ions. And how much this is OH ions in the solution, in the same solution will be 0.01. So this number is very, very large as comparison to this number. Got it? Got it?
Yes, sir.
So
Yes,
if
sir.
the question,
Yes, sir.
is being asked that do the basic solutions also have H plus ions, so what you will write? The answer, yes, the basic solutions also have the H plus ions. Okay. For examples, you need to explain this one with the examples. So note it down. The question, do the basic solutions also have H plus ions? Note this question first from here. Let's take the question. Now, I'm going to write the answer. Yes, the basic solution also have H plus ions. For example, if the pH of a solution is 12, then the H plus ions concentration in the solution will be 10 to the power minus 12 mole per liter, but the H plus ions, sorry, OH negative ion, but the OH negative ion concentration will be 10 to the power minus 2 mole per liter. Okay, which is since OH negative ions concentration is more than H plus ion concentration, hence therefore the solution is basic. It's basic. Note it down.
Noted, sir.
Everybody noted?
Yes, sir.
Shweta,
sir.
Yogita. Okay. Should I move to the next slide? Okay. So here we have another question. What is the effect of the concentration of H plus ions on the, what is the effect? Sorry, what effect does the concentration of H plus ions have on the nature of solution? So you know that if the H plus ion concentration is more, then it is acidic. If the H plus ion concentration is less, then it is basic. Got it? Got it? Will you be able to
Yes,
answer this
sir.
question?
Yes, sir.
Okay. Here it is, another that question that we were discussing previously. Let's take this one. So how is the concentration of hydronium ion affected when acid is being diluted? Let me explain you. When acid is being diluted. So let's take this question. This is important. If the hydronium ion is being written here, so what does it mean? Hydronium ions means H plus ions means hydronium ions means H plus ions. Okay, you can say that. If I'm saying hydronium means H plus ions. Okay, so if you're saying that, how does the concentration of hydronium ion affected when a solution of an acid is diluted? When a solution of an acid is being diluted. Okay, so if I'm having this acid, okay, and let's suppose it is, I'm going to give you examples. Okay, let's suppose this is a solution with pH 2. pH 2. Okay. Now this is 1 liter solution. This is 1 liter solution. Got it? Let me explain you, and you have to understood this concept very thoroughly. Okay, this is 1 liter solution. Okay. Then I add extra 9 water to it, 9 liter of water, or 99 liter of water is added to this one. That this is first 1 liter of substance, and I added this one to 99 liter. Okay. So let this is being poured. Okay. Let this solution is being poured into a bigger tank that is carrying 99 liter of water. 99 liter of water. Okay. Now this is the 99 liter of water, and you are pouring this solution to this one. Now the total solution will become how much? 100 liter? Everybody need to answer me, because this is an important topic. Okay. So Abhi, tell me how much the total solution, if you pour this one, then how much the total solution will become?
100.
100 liter. Shweb, Tejasvi, Shweta,
100.
why not?
Yes, sir.
Okay. Jobita, please answer the questions. Na?
Yes, sir.
Why are you so silent today? You're not speaking, not answering any questions. Okay, so 100 liter of solution, it will become. Okay. So actually, what is the concentration? Concentration, the definition of concentration is mole per liter. Means if I am saying that the pH of the solution is 2, just try to understand the concept, basic concept of this one. Okay? Just try to understand the basic concept behind this. That why does the pH on what factor does the pH of a solution depends? Okay. Let this is having the pH that is 2. Okay, and this is pH is 10 raised to the power, pH is 2. So the H plus ion concentration in this solution will be 10 raised to the power minus 2 in 1 liter. When this is being added to this one, now the total solution will become 100 liter. 100 liter now. Now when you add this one, 100 liter. Okay. And this the pH of this one will be, the pH of this solution will be 10 raised to the power minus 7. Sorry, pH is 7. So the H plus ion concentration in the of the solution will be 10 raised to the power minus 7.
Yes,
sir.
Because
Yes,
water
sir.
has a pH, water itself has a pH, na?
Yes.
So when you are adding 0.01 to 1, 2, 3, 4, 5, 6, 7, sorry, 0.01 is the 0.01 is the pH, is the hydrogen ion concentration of this. Okay, and 1, 2, 3, 4, 5, 6, 7, 8, sorry, 6. We have to add only 6. 1, 2, 3, 4, 5, 6, and this is 7. This is the hydrogen ions of this one. This means this number of H plus ions are present in this solution, and this number of H plus ions is present in this solution because pH is 2. So when you add this 2, will it be a greater effect of adding this 2? Means will this H plus ions will affect? For example, if you are having 10 lakh rupees and I give you 1 rupee extra, I give you extra 1 rupee. So will it affect 1 rupee in terms of 10 lakh rupees or 1 crore rupees? If I give you 100, you have 1 crore rupees, 1 crore, and I give you 100 rupee note. And I'm saying that this 100 rupee note will increase your wealth. So will it affect 100 rupee note
No.
in comparison to 1 crore? No. So if I add the H plus ions of this one, it is not going to affect such much. So the H plus ions of water will have no effect on it. Okay, because H plus ion of this one is very, very less as comparison to the H plus ion of this. This is very much great. Okay. So I'm now coming to this point is this is in 1 liter. Now this number of H plus ions is present in 1 liter. Now the solution has become 100 liter. 100 liter. So this the per liter, now the per liter will become, because H plus ions is always measured per liter of solution. Now the total this value of H plus ions is present in 100 liter of solution. So per liter it will become 10 raised to the power 0001, that is 10 raised to the power minus 4, and the pH of the solution will become 4. Got it? So when you are adding a solution of pH 2 in 99 liter of water, the pH of the solution will be 4. Why? Because the per liter of solution means it is now in 100. So these H plus ions will be divided, per liter will become 10 raised to the power minus 4. This will gives you 10 raised to the power minus 4 and it gives you what? You understood? You understood what I'm saying here?
Yes, sir.
Yes, sir.
Yes, sir.
Sure. So the pH is pH per liter of solution. For example, if I add this 1 liter of solution with pH 2, pH 2, that is going to, it means that the H plus ion concentration is 10 raised to the power minus 2 to extra 99 liter of water. So when you add 1 liter of this one, the total solution will become 1000 liter. Now the pH was 2 because the H plus ions of water is not going to affect anything. Okay, it's not going to affect. So now the pH will become, now you will get 10 raised to the power minus 5. Now the pH will become 5. pH of the solution will become 5. So when we are diluting a solution, strong solution, strong acid, the pH of the solution will increases. Okay, as the H plus ion concentration decreases, because initially the H plus ion concentration was 10 raised to the power minus 2, that is this one, and now the pH of the solution will become, so the H plus ion concentration will become this one. So this is decreasing. Okay, so if simply the question is being asked that how is the concentration of hydronium affected when the solution of an acid is diluted? So we will simply say that the concentration depends on the number of H plus ions per liter of solution, and if we are diluting a solution, then the H plus ions per liter will decreases, hence the pH of the solution will increases. Okay, got it? So let's write this the answer for this question. How does the concentration of H plus ions affected? Okay, so note down. So note it down. The concentration of H plus ions or hydronium ions, okay, is the number of moles of H plus ions present in 1 liter of solution. Okay, if the solution is diluted, if the solution is diluted, then the number of H plus ions per liter will decreases, and thereby results in increase of pH of solution. Increase in pH of solution. You understood? The concentration of H plus ion is the number concentration of H plus ion is the number of moles of H plus ions present per liter of solution. Okay. If I'm saying the pH of a solution is 2, it means 10 raised to power minus 2 mole of H plus ions is present in 1 liter of solution. So this means, okay, in 1 liter of solution. If we are increasing the number of liter of solutions, so per liter of H plus ions will decrease. Okay, so this will result in, you understood? Are you getting my point clearly?
Yes,
Yes, sir.
Everybody, Abir, Shweb.
Yes, sir.
Okay. So let's move further. Have you noted this one?
Yes,
Yes,
sir.
students.
Yes, sir.
I need to remind you that we will be going to discuss some other topic in the 9:30 class. Okay, because we are just going to have the test on Friday, so we are just preparing for this one because the exams are nearer. Okay, so please, you need to join again at 9:30. A different topic will be teaching you, so don't think that you are
Sir,
studying the same
today?
topic. Yes,
today-
today. Yes, you
Sir,
have at 9:30 according to the Indian timings.
okay, sir.
Or okay, so you need to join that one because we are just preparing for exams. Exams are nearer, so we need to uh, revise each and everything properly. Okay, which is coming in examinations. Okay, so next question that comes regarding to this one is, while diluting acid, why it is recommended we have done this one? How is the concentration of OH ion affected when excess of base is dissolved in the in a solution of sodium hydroxide? So question, you need to answer these questions. Please answer this question. Question number 6. What you will say this the answer for this question? How is the concentration of hydroxide ions affected when excess of base is dissolved in a solution of sodium hydroxide?
The ions are the concentration is increased because it is base added to a base.
The concentration of OH ions will increases. Okay. If the concentration of OH ion increases, will the concentration of H plus ion increases or decreases?
Decrease.
If I ask you, the basic solutions also have H plus ions? Shweta,
Yes,
you need to answer. Shweta, you need to answer that will the basic solutions also have H plus ions?
yes, sir. Bases will also have H plus ions.
So
Because
you need the H plus, here the concentrations means the number of OH negative ions per liter of solution. So when excess of base is dissolved in a solution of sodium hydroxide. So if we are increasing sodium hydroxide and excess of base is dissolved, so the concentration of H plus ions will also increase. Okay. Got it?
yes,
So let's move further. And we have done this topic. So let's do the very important part of this. Okay, wait a minute. Let's do some important questions regarding to this chapter. Let's we have this. Question number 8, which one what is the answer for question number 8?
option C.
Acetic increasing order of your acidic strength. Okay. So acetic acid, then water, then hydrochloric acid.
option A.
Option A. Option A.
Option,
Option A.
option A. So water is neutral, acetic acid is weak acid, and then hydrochloric acid. Yes. Acidic strength, increasing order of your acidic strength. Okay. So that is correct. Option A is correct. Okay, tell me which one is correct? Question number 14.
higher the pH, weaker the acid.
Higher the pH, weaker the acid. Okay, you need to choose two. Higher the pH, weaker the acid. Other,
Option 2 and 4.
lower the pH, weaker the base. Yes, option 2 and 4 is the correct one. Okay. Which among the following is not a base? Question number 23. Which is not a base?
Option D.
Option D. Please note it down this question that still it has OH negative ion. So it is an alcohol. C2H5OH is an ethanol. It is a type of alcohol that we're going to study in the 4th chapter, okay, of chemistry. So please note it down. Note this question in your copy that which of the following is not a base, and please note this question in your copy. Done?
Yes, sir.
The
Done,
type
sir.
of question. And everyone is requested to please join the class on their time. If it is 7:30 given, then 7:30. If it is 6:30, then sharp 6:30. Okay, you need to join the class. Strong acid and weak acids. Okay, do this question. Identify the compound X on the basis of the reaction given below and write the name of the compounds. Can you tell me? We have done this one in the previous class. So which one is correct? Zinc when react with compound X, it gives A plus hydrogen gas that we have done in the previous class. Okay, and similarly, this HCl also react with this compound, it also gives water. Okay. And here when it react with this one, it also gives water. So is there any idea regarding to this one? This for this question.
Sodium hydroxide.
Sodium hydroxide. Okay, and what is A?
Sodium zincate.
Yes, it will be sodium zincate. So we have done this one. Shweta, we have done this one in the previous class. Shweta, you are correct. The name means, is I'm correctly pronouncing your name? It is
Yes,
Shweta.
sir. Yes, yes.
So if I'm saying this one is compound X, okay, and this is NaOH. Why I'm considering NaOH? Let me explain. This is X compound when react with metals. It produces hydrogen. A plus means salt plus hydrogen gas. So it may be an acid or a base because acids when react with acid when react with metals it produce hydrogen gas. And base also react with metals like zinc, platinum, zinc, lead, and aluminum. These three metals when react with base, they also produce hydrogen gas. So it is zinc here. So it may be acid or a base. Now here, if it is acid, then acid will not react with acid. So it is confirmed that it is not an acid. Now it is base. A base when react with acid, it gives you salt plus water. Now it is base. And this also, it also reacts with sodium water. So we have to write the correct equations for each and everything, for each part. So here we are writing, if it is NaOH, then it reacts with zinc. It will give you sodium zincate, Na2, ZnO2, sodium zincate plus hydrogen gas. This we have studied previously. Now NaOH when react with HCl, it gives you NaCl plus water. And NaOH when react with CH3COOH, acetic acid, it will give you CH3COONa, sodium acetate plus water. So know these equations. Done.
Yes, sir.
Yes, sir. Done.
So that's all for today. Okay, we're going to discuss this one in the next 9:30 class. Please, everyone need to be present there because we're just going to discuss the important topic of this chapter.